Alright, so I'm going to be proving that 0 divided by 0 is equal to 2. So to do this, I'm going to first start with 0 divided by 0. So 0 divided by 0, this is the same thing as 1 minus 1 over 1 minus 1, because 1 minus 1 is 0, so 0 over 0, 1 minus 1 over 1 minus 1. Now 1 minus 1 over 1 minus 1, this is the same thing as 10 minus 10 over 10 minus 10. Again, 10 minus 10 is 0, so I have 0 over 0 again. Now 10 minus 10 over 10 minus 10, this is the same thing as 100 minus 100 over 100 minus 100. Again, 100 minus 100 is 0, so it's the same thing. Now I'm actually going to simplify 100 minus 100 over 100 minus 100. So 100 is the same thing as 10 squared, right? So this is the same thing as 10 squared minus 10 squared for our numerator, because 10 squared is 100, so 100 minus 100 is the same thing as 10 squared minus 10 squared. And for my denominator, 10 squared, this is the same thing as 10 minus 10. So I'm going to write 10 times 10 minus 10 times 10. And this is again equal to 0. This is still 0 over 0. And now if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So 10 squared minus 10 squared, this is equal to 10 plus 10 times 10 minus 10. So again, this is completely legal. I'm just using a property of exponents. And for my denominator, I'm actually going to factor out 10. So now I get 10 times 10 minus 10. So now I can actually go ahead and cancel these two 10 minus 10s out. So now I'll be left with 10 plus 10 over 10. 10 plus 10 is 20, so I have 20 over 10, which is equal to 2. So I just proved that 0 over 0 is equal to 2. Now obviously 0 over 0 is not equal to 2, and the mistake in this proof is right here when I canceled out 10 minus 10 over 10 minus 10. So what is 10 minus 10? 10 minus 10 is 0. So I'm technically canceling out 0 and 0, and remember, 0 over 0 is not equal to 1. So I can't actually cancel these two out, because that's essentially implying that 0 over 0 is 1, which it's not. So that's a mistake in this proof, and 0 divided by 0 is not 2. Alright, so in this problem, I have 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 999. So to solve this, I'm going to first start by factoring out 3 to the power of x. So now I have 3 to the power of x times 1 plus 1 plus 1 is equal to 999. Now 1 plus 1 plus 1, that's equal to 3. So now I have 3 to the power of x times 3 is equal to 999. Now I'm going to go ahead and divide both sides by 3. So then these two cancel out, and now I have 3 to the power of x is equal to 111. Now if I take the log on both sides, I have log 3 to the power of x is equal to log 111. And if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is equal to b times log a. So for log 3 to the power of x, I can move x to the front. So now I have x times log 3 is equal to log 111. Now if I divide both sides by log 3, these two cancel out. And now I have x is equal to log 111 over log 3. Oops, sorry, I think I made a mistake here. 999 divided by 3 is actually 333, not 111. So this is going to be log 333 over log 3. And now I'm going to rewrite log 333 as log 111 times 3 over log 3. And if I have something in the form log a times b, this is equal to log a plus log b. So log 111 times 3, that's going to equal to log 111 plus log 3 over log 3, which is the same thing as log 111 over log 3 plus log 3 over log 3, which is 1. And log 111 over log 3, that's the same thing as log base 3 of 111. So this plus 1. So this is my answer. Alright, so in this problem, I have 5 to the power of x plus 25 to the power of x is equal to 20. So to solve this, I'm going to first rewrite 25 here as 5 squared. So now I have 5 to the power of x plus 5 squared to the power of x is equal to 20. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So 5 to the power of 2 to the power of x, I can switch the places of 2 and x. So now I have 5 to the power of x plus 5 to the power of x squared is equal to 20. Now I'm going to let 5 to the power of x equal to the variable y. So now if I substitute in y for 5 to the power of x, I get y plus y squared is equal to 20. And I can rewrite this as y squared plus y is equal to 20. So now I'm going to subtract 20 on both sides. These two cancel out, and I have y squared plus y minus 20 is equal to 0. So now all we have to do is simply factor this out. Y is the same thing as 5y minus 4y. So now I'm going to factor by grouping. So first, from here, y squared plus 5y, I'm going to factor out y. So I get y times y plus 5. Minus from 4y minus 20, I'm going to factor out negative 4. So I get negative 4 times y plus 5 is equal to 0. So now if I factor out y plus 5, I get y plus 5 times y minus 4 is equal to 0. So now this is going to give me two equations. I have y plus 5 is equal to 0, and I have y minus 4 is equal to 0. So for y plus 5 equals 0, y is equal to negative 5. And for y minus 4 equals equal, y equals 4. Now remember how we let 5 to the power of x equal to y. So now this is going to give me two equations. I have 5 to the power of x is equal to negative 5. And I have 5 to the power of x is equal to 4. So first off, 5 to the power of x equals negative 5. Well, I can't take the power of a positive number and make it a negative number. So this is wrong. This equation is wrong. So now this leaves me with 5 to the power of x equals 4. So to solve this, I'm going to first take the log on both sides. So I have log 5 to the power of x is equal to log 4. This is the same thing as x times log 5 is equal to log 4. And if I divide both sides by log 5, I get x is equal to log 4 over log 5.